We've all seen this pattern, right? In almost any complex system, a problem pops up, a fix gets applied, and for a little while, everything seems to be back to normal. But then, sure enough, the same problem comes back, needing the same fix all over again. It's this endless cycle. And the common assumption we all make? That someone, somewhere, is just making a mistake. But what if that's not what's happening at all? What if that view is completely missing the point?
If you look closely at any complex system, you'll find a stated goal, something like solve the root cause. That's what the system says it wants to do. But then, if you watch what it actually does, you see a totally different pattern, a consistent, almost gravitational pull toward quick fixes that only ever patch up the symptoms. You see, this gap between what's intended and what happens, it's not some random error. It happens so often, it's clearly a feature, not a bug. And that really brings us to the heart of the matter here. Is the system genuinely failing every single time it opts for a temporary patch? Or is this behavior something else? Is it an emergent property that comes from the system's own structure? An outcome that, in a really strange way, is not only logical, but maybe even inevitable, given the forces acting on it. Okay, so to really get our heads around this, let's break down the fundamental choice a system has to make whenever a problem appears. When something goes wrong, it's presented with two very different paths it can take. It all starts right here, with a problem symptom. This is the thing you can see, the part you can measure. It's the signal that's screaming for attention, the part of the problem that's painful enough to force some kind of response, and fast. Now, here's what's so fascinating. The two paths aren't really defined by what they do, but by their core properties, how they work. On one hand, you have the symptomatic solution. It's fast, its results are obvious right away, and it doesn't take a whole lot of effort. On the other hand, you have the fundamental solution, and it's the exact opposite. It's slow, the benefits take forever to show up, and it demands a ton of resources. You know, when you just look at them side by side like this, you can immediately see the appeal of the easy path. But, and this is the key, choosing that easy path isn't a one-and-done decision. It actually kicks off a chain reaction that builds a kind of structural trap. It's a trap that makes it harder and harder to ever leave that path of quick fixes. In systems thinking, this whole dynamic has a name. It's called shifting the burden. To see how this trap actually works, we first need to understand a core concept, the balancing feedback loop. Just think of it like a thermostat in your house. It's a self-correcting process. It's an action that works to close a gap and push a system back to where it's supposed to be, keeping things stable. So that symptomatic solution, that quick fix, it creates exactly this kind of balancing loop. You apply the fix, it acts directly on the symptom, and the symptom goes down. The pressure is off, and the system looks stable again. From the inside, it feels like a total success. The fix worked, but that is nowhere near the end of the story. Because every single time that fix is used, it produces an unintended side effect. And this side effect is usually invisible, at least at first. It just slowly builds up under the surface. And this is where the entire structure of the problem starts to change in a fundamental way. You see, this side effect creates a totally different kind of feedback, a reinforcing loop. Now, unlike a balancing loop that stabilizes things, a reinforcing loop does the opposite. It amplifies whatever's already happening. It creates exponential growth or collapse. It's what we usually call a virtuous cycle, or in this case, a vicious one. So how does this vicious cycle actually lock the system in? Well, that unintended side effect from the quick fix starts to actively sabotage the system's ability to ever use the real solution. So with every patch you apply, that fundamental long-term fix gets more expensive, more difficult, or just seems less and less necessary. The entire burden of solving the problem has now been shifted onto that temporary fix. Let's make this a little more concrete with a quick abstract example. Imagine you have a component in a machine that's slowly degrading. You apply a temporary patch, and boom, performance is back to normal. To an outside observer, the system looks totally fine. But the patch is just masking the problem. The component is still degrading underneath. That makes the eventual replacement even harder. And every time you reapply that patch, a hidden vulnerability is just silently growing. Okay, so we have these two loops, one that balances and one that reinforces, and that explains the structure of the trap. But that alone doesn't really explain why the system so reliably chooses that path. To understand that, we have to go one level deeper and look at the feedback that each path gives back to the system. And the difference is just staggering. The feedback you get from the symptomatic loop is immediate, and it is loud.
The problem gets better right away, so the link between what you did and the result is crystal clear. It's a strong, fast signal that powerfully reinforces that action. Now compare that to the fundamental solution. Its feedback is delayed, and it's weak. The benefits show up so much later that it's actually hard to prove that your initial hard work was the cause.
The thing is, any system, whether it's biological or organizational, it learns from feedback. And just like an animal being trained with an immediate treat, the system is essentially trained by that faster, stronger signal from the quick fix. It learns to prefer the path with the quickest reward. So that explains the preference, but it still doesn't tell us where the initial pressure to make that choice comes from in the first place. And this, right here, brings us to the very deepest layer of this whole explanation. It turns out that this preference for the symptomatic path isn't random at all. It's actually driven by a universal constraint, a fundamental trade-off that is baked into almost every complex system you can think of. It's known as the efficiency-thoroughness trade-off, or the ETTO principle. And it's really simple. It just says that in any system that has limited resources, you can't be both maximally efficient and maximally thorough at the same time. You can do something fast or you can do something right, but you can almost never do both. I mean, just think about it. Every system is working with limited time, a limited budget, limited attention. Those constraints create this constant nagging pressure to be efficient, to get the most result for the least amount of effort. And if we look back at our two solutions, which one is the more efficient choice? Well, by definition, it's the symptomatic one. So the choice to take that path is really just a choice to prioritize efficiency, which means you have to sacrifice thoroughness. And this is such a critical insight. From this point of view, the choice isn't a failure of judgment. It's actually a perfectly rational, local optimization. When you're faced with tight resources and urgent demands, the system is making the most logical choice available to it in that moment. The real trouble starts when all of those locally smart decisions pile up and create massive unintended consequences for the system as a whole. All right, so now we can finally put all the pieces on the table. And when we do, we can see the full picture. A system that isn't actually broken, but is instead perfectly designed to produce the exact behavior that seems so irrational to us on the surface. So let's just trace the logic one last time. It starts with a pressure for efficiency, which is born from resource constraints. That pressure always nudges the system toward the symptomatic solution. That one choice then triggers two powerful feedback loops. The first is that fast, balancing loop that makes the symptom go away, which powerfully rewards the initial choice. But at the same time, that second, slower, reinforcing loop is working in the background, eroding the system's ability to ever solve the real problem, and locking it into a dependency on the quick fix. What we're really looking at here is an emergent behavior. It's a textbook case of how a whole bunch of locally smart decisions can add up to a globally irrational outcome. And over time, this dependency on the quick fix isn't temporary. It becomes a permanent part of the system's structure. The failure we see isn't the system breaking down. It's the system finding a new, perfectly stable, and deeply dysfunctional way to operate. So the next time you see a system just treating the same old symptom over and over again, remember the structure. It might not be a sign that the system is broken. It might actually be the sign of a system that is successfully and rationally optimizing for short-term survival under constant pressure. It's a system doing exactly what its structure incentivizes it to do, whether we like that outcome or not.